We'll now talk about the client that we can use for the myLinkedList class. Just like we did with the myArrayList class, we can create a client for the myLinkedList class. And what we're going to see when we run through the code is we're going to use the exact same client as we did before. The only difference is we're changing the type of the object. So we're, instead of getting an object of myArrayList, we're going to get an object of myLinkedList. That's the only change we're going to make. All of the methods that we're going to have are identical, and the output is identical. So what you should see when we run the client is that there is no difference between running the client for myLinkedList than running the client for myArrayList. In fact, the only thing you're really going to see is we're using the word linked instead of the word array in the name of our class. Let's go ahead and implement our client now for the myLinkedList class. What we're going to see, this is going to be nearly identical to the client for the myArrayList class, except we're going to use the myLinkedList class instead of the myArrayList class. Now, I could just take the client for myArrayList and just copy it and then just change a few things, but we'll just go ahead and write the whole thing from scratch, just as a good review for us. So let's go ahead and create a new program. We'll import the util package, so java.util.star. We need our class. We'll call it myListClient. And then we need our main method. Okay, so now we need to create an object of the myLinkedList class. So we'll do myLinkedList, integer, and then myList equals new myLinkedList, integer. There we go. And now from this point onward, we're just going to use the same stuff from the previous client, except now we're going to call the methods from the myLinkedList class that we have here. So we'll add the same elements before. So we'll have mylist.add. So we'll do the same numbers. Just that way you can see that there isn't any difference from the client perspective. However, as we already know, the difference is done at the implementation level. So the user sees the same methods and they know what is being done, but how that's actually being done is very different. So let's print the contents. So we'll use a for loop. So do mylist.size to get the size of the list. And then we'll do mylist.get. And for example, like this get method, with a linked list, we know that we have to search the entire list, or at least half the list, to find the element that we want. Whereas if we're doing an array, we can directly access that element. That's just one of those differences between the two underlying data structures. Let's go and compile this to make sure everything's working properly. And we got to save it as myListClient. Okay, everything worked just fine, so let's just run it. So let me run. Okay, so we did one line at a time. Okay, so I just need to change this right here. Let's try that again. I want to print everything on one line, just like I did in the client. There we go. So there's that. We can use the iterator just like before, so we'll go ahead and create an iterator. If I could spell it correctly, that'd be good. We'll call it iter1. MyList.iterator, so we'll use the iterator method. So we can use a while loop to make sure that there is something next. And then we'll print. We use the next method. And we can make sure that works. Let's compile and then run it. And that works as well. So iterators work just fine. Let's go ahead and remove an item. So we'll do like we did before. We'll store that in X, even though we don't really print X, but we could do something with it later if we wanted to. We'll use the remove method. And we know at this point the last iterator was invalid. So I'm just going to copy this code. And I'm going to call it iterator2 or iter2. So let's make sure this works. So we'll actually see the removed element.
So there we go. The second element was 15, or index 2 is 15, so we print 5, 10, and 20. The 15 is no longer there. And then let's go ahead and change an element. To do the set method, we'll set the item at index 1 to 12, so that should change the 10 to a 12. And then we'll print our contents again using another iterator. So I'll just paste the stuff from before. That should be, oh, we need right here. There we go. So let's compile to make sure that works. And then we can run it. And sure enough, the last print there does print a 12 for index 1 instead of 10. So this is the exact same client as we did with the myArrayList class. The only difference here is we have linked instead of array. But everything else here, if you want to pull out the ArrayList client and take a look at it, you'll see that the code here is exactly the same except for this one line right here. That's the whole point we're going to get at. For the user, they don't see what is the underlying data structure. If I were to change this class to something else, something that did not reveal what the underlying data structure is, the user wouldn't be able to tell. All the user could tell was just there is some type of list. We can add stuff to it. We can print stuff either directly using the get method or an iterator, or we can remove stuff. We can set things. We can do all sorts of stuff, but we do not know what is the underlying data structure or how it's being done unless we were to look at the implementation itself.
So the fact that we didn't see any difference in the output or the method calls is exactly what we want to accomplish with object-oriented programming. These are the goals for both abstract data types and for object-oriented programming. Our client is going to provide with the what part of the program. It's going to tell us what we want to do with our programs or with our abstract data types. And our class is going to provide how we want to implement those operations. So the client should not give any indication or any information about what's actually going on in the class, such as knowing what the underlying data structure is. If we look at the client, you shouldn't be able to tell if we're using an array data structure or a linked list data structure. All of that work should be done in the class definition. So the way I usually explain it to my students is the client is telling us what we're going to be doing. The class is going to tell us how we're going to go about doing it.